Okie dokie, okie dokie. Let's go through and categorize some of these integrals. So these come from old finals. So on a final or a test or a quiz, you got a bunch of integrals in front of you. I would encourage you to first of all just categorize them, okay, before you do any calculation. And I would also encourage you to just do the easy things first. So first question, okay, I can see right away that this is going to be simplify. So that's pretty straightforward. I got 3 pieces here. I break it up into 3 separate fractions, 3 separate integrals, and I go from there. Okay, so number 1, or part A, is simplify. What's the next one? What's jumping out at me? What is really jumping out at me here, right? So B is a little bit ambiguous. I'll leave that aside. But what's jumping out at me here? Okay, G. Okay, G right here. Okay, this is just screaming at me. Screaming at me, well, I can see that the degree on top is 4. Degree on the bottom is 3. Okay, so this is going to be start with a long division for G. Okay, that's that one done, that one done. What else is happening? Okay, obviously F, right? F, absolute value. So I use my absolute value techniques. Okay, fine. Now we'll say E. E we can just ignore. E is something we're not doing in the course this semester, so don't worry yourself about E. Okay. What else is happening here? How about B? Now we'll contemplate B. Now B is, well, what's left here, right? We have probably by parts or substitution. Now if I look at B and I look at the inside function, so the inside function is this ln x plus 1. And then what's going to happen when I use that in a substitution? Well, it's going to cancel this x here. Okay, I can see that because I've practiced a lot. But that's really the only way to do it, right? You have to practice a lot, and then I can see that u equals ln x plus 1 is going to kill this x here. Perfect. So B is a sub. C, also a sub. Again, if I take u equal to sine squared x plus 7, I know, because I'm pretty sharp on my derivatives, that the numerator will cancel. So this is also a sub. D. D, the inside function is 4x. If I let u equal 4x and do a sub, not going to help me here. So integration by parts. Okay, the last one is H. Last one is H. Does not appear to be an inside function. Okay, you could try letting u equal ln x, and if you do u equal to ln x, that is not going to help you with this x over here. So this one again, I would do by parts. Okay, let's do another one. December 2016 exam. So let's see, what are these ones are C and D are jumping out at me. Okay, those are pretty obvious what I should do there. Okay, I got absolute value here. And I got, this one is the degree on the bottom is larger than the degree on top. So I go right into partial fractions. Okay, part F, again, we're not going to worry about those this semester. We've decided not to emphasize those this semester, so don't worry about that one. First one. Okay, just if you think about this, if I go u is the inside function as a substitution, what am I going to get? I'm going to get 2x plus 3. And that will indeed help me cancel the 8x plus 12 over here. If you don't see what I'm talking about, give it a try. But I am convinced already this will be a sub. Part B. The inside function is 2x. That's not going to help me. So letting u equal 2x will not help me with the x cubed plus 2x over there. So this is going to be an integration by parts. Part E. 3 pieces. Seems like I should break this up into 3 separate integrals. So this is simplify as my first step. Okay, G is a tricky one. Okay, the tricky ones I think you may have noticed are, either going to be integration by parts or substitution. So I would say, it's going to be a substitution here. If I start wrongly and do integration by parts, you're going to run into a roadblock pretty quickly. So then you'd come back and try a sub. Okay, so again, you have, a bunch of integrals in front of you. It's a good tactic to go through and just classify them quickly. And then do whatever you find easiest. And then move on to the harder integrals later. Okay, one more. The winter 2015 exam. So first one. Okay, hopefully you've seen a pattern here. Three fractions, 3 integrals. I should simplify here. Okay, B is a little bit tricky here. Let's see what's happening here. Now, if I go u is equal to t cubed plus 3t, you just quickly go t cubed plus 3t prime is 3t squared plus 3, which is 3t squared plus 1. Aha. So I will cancel this thing here. So what does this tell me over here? It tells me that a substitution is going to work quite nicely for part B. C. The degree on top is the same as the degree on the bottom. That is long division. I must begin with long division. Part D. Part D is I don't see an obvious inside function. And it's not a partial fractions at the ln x present. So integration by parts is my choice here. Part E, degree on top is smaller than the degree on the bottom. So I would do partial fractions here. Okay, part F, the derivative of cotangent. The derivative of cotangent is negative cosecant squared. Okay, so this tells me that a sub is certainly called for here. Part G, the inside function, 2x isn't. If I do if I do a sub u is equal to 2x, it's not going to help me with these x's over here. If I do a sub u is equal to x minus 8, that's not going to help me with this 2x over here. Okay, so substitution I don't think would lead anywhere, so I am motivated to try integration by parts. Okay, I'll repeat it again. You have a bunch of integrals in front of you. You should classify them. And then try the one that you think is easiest. And then the next easiest. And then finally work your way up to the harder ones.